The topic is streamline flow. The flow of a fluid which its velocity at any point is constant or changes at regular manner, then that flow of fluid is known as streamline flow. If there is no loss of fluid within the uniform tube, the mass of the fluid flowing into the tube at any given time is equal to the mass flowing out of the tube in the same given time. Okay. Now let us see the picture that you can understand how to define a streamline flow. So this is the point P. Let the mass M1 passes through the point P, that is A1 is the cross section area of the tube. The fluid entering into the tube with the velocity of V1. In the same way, let this is point Q and let M2 mass is passing through this Q and whose cross-sectional area is A2. Let the velocity of the fluid leaving point is Q2. As M1 is entering the tube at P of cross-section area A1 with velocity V for time T. Okay, then the mass entering the tube in time T is given as M1 is equal to rho V1. Here rho is the density of the fluid and V1 is the velocity, that is volume of the liquid entering at the point P. Then A1 is the area of cross section. Okay, so rho V1 is equal to rho of A1 x1. x1 is the distance travelled by the fluid in time T, which is equal to rho into A1 V1 into T. Okay, so this is the equation 1. Similarly, let the mass M2 is leaving the tube at point Q of cross-sectional area A2 and moving with velocity V2 for time T is given as M2 is equal to rho V2. So rho is the density of the fluid, we know. V2 is the volume of the liquid that is leaving, okay, leaving out from the point P, which is equal to rho of A2 x2. A2 is what? Cross section area, and x2 is the distance travelled by the fluid in time T, and which is equal to rho A2 V2 into T. So this is the equation number 2. If since the mass is conserved, we have M1 is equal to M2. So we have to write the equation 1, which is equal to equation 2. So if you are writing the equation 1 and equation 2, we get rho into A1 V1 T is equal to rho into A2 V2 into T. A1 V1 is equal to A2 V2. Rho and T will get cancelled. This equation is known as the equation of continuity. So we can also write AV is equal to constant. Okay. This is also known as flow rate equation. Next topic is turbulent flow. That is, a fluid flow is said to be turbulent if the velocity of the particles vary at any point erratically. That means there is no order or there is nothing happened in an original fashion. It is something like the fluid particles keep moving here and there with any random velocity. So any particle can have any velocity at any point of time. So there is no particular organized way of flow of the particle. Okay. So now eddies are generated in this flow. Do you know what is eddies? So eddies are something short of ripples. If you observed, when we throw a stone on the river, you get ripples kind of force. Those are something called eddies. So eddies are some erratic motion which takes place due to random flow of particles here and there. Look at this picture, the laminar and turbulent. In laminar flow, you can see that all position of particle are moving in a path which are parallel to each other in a proper fraction. That is, at every point all the velocity has same velocity. None of them are intersecting each other. Whereas when we come to turbulent flow, you can see that all the particles are moving randomly here and there in any direction. So the turbulent flow is completely opposite of laminar flow. So the steady flow got 3 different names, that is steady flow, streamline flow and laminar flow. So this is what